I'm Dave Morris, Delivery Director in REWE Digital here in Germany. It's a pleasure to be with you here today, and I wanted to share our story of our journey from monolithic architectures to microservice architectures, and perhaps some of the successes and learnings that we had along the way. Before I do that, I wanted to talk a little bit about the REWE Group. The REWE Group is around 90 years old, over 60 billion euros turnover, present in about 14 countries in continental Europe. It's headquartered in Germany, has around 350,000 staff, around 15,000 shops. REWE Digital, we are in the REWE Group. We're the digital services provider for the group, so we provide all the classical things you'd expect us to provide. We have a click and collect service, a parcel service, and two types of delivery services. That's the one locally centered around particular shops. So a shop owner can decide to have their own local delivery service, and the more classical one, which is one from central warehouses all across Germany. There are roughly 9 central warehouses, or we call them food fulfillment centres, and one of those is the largest automated fulfillment centre in Europe at around 15,000 square metres. Around 2,000 people work in our organisation as a whole. When we talk monolithic and microservices architecture, it's not really a question of one is good and one is bad. I don't mean to say that microservices are better than monolithic architectures. It really depends on your business and the situation you find yourself in. I really contrast the difference between being short-term greedy and long-term greedy. So with monolithic architectures, there's obviously a high initial speed to the market. There's a lot of functions you can get in quickly into your environment and get trading with the customers. They're relatively easy to manage because the one block that goes into production, and they've got some well-known conditions and issues that you need to manage. And of course, everything's orchestrated from within the same architecture. So the UI, the business processes are all controlled within that platform. Contrasting that with microservices then, there's a faster speed to react to market change. So when microservices architecture, we build small business functions called services, and we can change those services quite quickly. They're relatively easy to change in comparison to Monolith. So if you change, say, the checkout function, it doesn't tend to affect anything else in the ecosystem because the microservices tend to be independent of one another. And because of that, there's also fairly low deployment and service risk. So if one of the microservices goes down or becomes disturbed, then it doesn't necessarily impact on the rest of the ecosystem. Whereas, of course, in the monolithic environment, if you have the monolith go down, the whole shop goes down. So trying to run an analogy to music, this chap is a one-man band, can quickly get into the market, manages himself, orchestrates himself, can earn money quite quickly. It takes time to build an orchestra. It can be quite expensive. You have to coordinate and orchestrate these. It's more difficult to manage it. But once you have it, of course, you can play different music to the one-man band. And of course, if one violinist loses their arm, heaven forbid, the whole orchestra can go on. Whereas if the one-man band loses their arm, it's quite difficult for him to continue to play. Right, so on to our journey then. What did we find in our journey from monolith to microservices? So I set this in the context of sort of a geology, really, a chronology of events that happened over a 5-year period from 2014 to 2019. I'll give you a little update of what's happening in 2020 at the end. And we start really with the first period of this structure, which we can call the monolithic, and here we have effectively one dominant central creature in the environment, a very big animal. And this sort of period lasted for 1 year in our organisation. Here we had this one great monolith of a shop, effectively linked to a single pipe out to a legacy external world, which itself was complex. So monolith structure quite complex, a lot of spaghetti code in there, legacy external quite complex, 4 teams working in that environment because it was hard to scale the number of teams to work on it. So we had a situation really where we were trying to keep the stakeholders away because making change was pretty hard and complicated in that environment. Classical really deployment pipeline to live for software. So 4 teams working semi-independently, I'd say. So they had a different focus within the monolith. On a sprint cycle, coming together at the end of the 2 weeks and then finding all the normal problems when they were integrating and merging the software. A lot of swearing, a lot of anger, a lot of frustration. Software then moved through a process of testing through a testing suite, and then into an integration environment with more tests, and then it was fairly manual from that point onwards, moving it to pre-production environment and then eventually to production. Obviously in pre-production you test other things, including manual tests and performance tests and security tests. So fairly traditional pipeline. What was interesting was the test suite itself was very unbalanced from our perspective. So the blue colour there represents the unit tests, and the red colour represents the UI tests. And what you typically see in a typical pyramid is a small number of UI tests. We had a very large number of UI tests. So this was really the only way to regression test and functionally test the monolith at this point. And a very small number of unit tests, which helped prove the software was of good quality. This was a real problem for us because fairly obviously UI tests are reasonably fragile. So painting a picture here, really, the monolith, we had a fairly complex environment, fairly high levels of fragility, difficult to refactor the software, difficult to move the software forward, difficult to change it, keeping stakeholders away, not a great picture. We wanted to change. So the next year we embarked on the next phase, which called the lower microservices period. And this was characterized by the big creature becoming slightly smaller creatures and starting to look a little bit more like furry mammals. What did we see here? Well, the first thing to say that we did, there wasn't an awful lot of focus on functionality in the first phase, believe it or not. What we decided to do was focus on the platform itself. Yeah, so we chose a hosted platform, Docker images, those types of things. We've subsequently moved to the cloud, but okay, we took a decision then, and now we've migrated. And the early microservices that we built weren't there to prove functional change on the platform. They were really there to prove that we could use that new platform that we put in place and that we could build microservices. So in fact, those very early microservices were in fact probably merely databases with a small amount of business logic and an API. Right? But the key thing we were proving there was the technology, the architecture. Of course, they did bypass some of the monolith for us. Yeah, they did bypass some of that functionality, which was always good for us because we didn't have to work on that area of the monolith. But that was fairly limited. The number of teams roughly doubled, so we went from 4 teams to 9 teams during this period because we could start scaling out new teams to start working on new microservices. How were the teams organized? Well, roughly 4 teams working on the original monolith and the new teams starting on the new microservice. So a fairly hard split there. The deployment cycle for the monolith stayed around every 2 weeks at the end of a sprint cycle, whereas, of course, with the microservices, much more flexibility there. They were delivered on different technologies, the technologies that suited the business scenario, so either functional programming or standard Java or whatever. And we could deploy those every single day, multiple times a day. We didn't have to deploy them if we didn't need to, this type of thing. The deployment pipeline changed a little bit, so there was in fact 2 deployment pipelines. The inner pipeline is one we've already seen, which was the traditional Monolith deployment pipeline, but a new pipeline was introduced, which was more fully automated now. And of course, because the microservices being built were independent of one another, there was no integration effort between teams. Yes, of course, there was integration emerging within the team, but not between teams. So it removed a lot of the frustration. Also, it helped us build something more stable because we started with a sort of bottom-up process of testing. So a lot more emphasis was put on unit tests, philosophies like test-driven development, etc. And started looking at functional testing as well, using Jeb and Spot framework to ensure that we could cover the functionality of and API testing as well. And obviously a small number of UI tests where possible. And then this went all the way through to the pre-production environment in automated manner, the final step, of course, being manual. What did we see in the testing pyramid then? We saw the emergence of, or the clash of 2 pyramids, if you like, the old pyramid and the new pyramid. The old pyramid representing the heavy number of fragile UI tests in the monolith, and the new world of lots of unit tests and functional tests fully automated in our test environments. But interestingly, we started to see a bit of finger pointing between the teams working on the monolith and the teams working on the new microservices. So when we did have defects or incidents or whatever happened, they'd both be looking at each other, sort of blaming each other for those issues. That led to the introduction of what we called the guilds. The guilds were informal virtual teams, but we expected one member from every team to attend a guild. Yeah, so that there was all those team members got to mix, resolve issues before they became issues, if you like, on specific topic areas, whether that was a security focus or a UI focus, UX focus, architecture focus, or whatever it was. Yeah, there were certainly more topic areas than that, but really enhancing discussion and communication across the organisation. Right, on to the next period, which is the middle microservice. Here the comet really hit. So we started to extinguish, I should say, the dinosaurs at this point, and really we had started to build lots of small furry animals, which obviously analogy to the microservices themselves. Again, we saw an explosion of teams. Why did that happen? Well, there were two major technologies that were introduced in this period. So the first was internally written DUC, we call it, so the dynamic UI composition layer. What was happening previously in our environment was all the UI orchestration was still being done in the monolith. So however much functionality you built out in the microservices, still had to route back into the monolith to orchestrate. Now, building the DUC set us free effectively from the monolith. And now all microservices could write their own UI and coordinate those, the HTML, the content, etc., through the DUC. The second technology was Kafka, message queuing, so allowing for asynchronous communication internally within our microservices ecosystem and even externally to third parties as well. So both these were game changers for this, and we saw the number of microservices start to accelerate rapidly, because not only could we build lots more microservices, we could build a lot more features within the microservices as well. And this led to a massive reduction in activity on the monolith. Also, because the number of teams in ecom went from 9 in the previous period to around 20 in this period, we split the organisation up into tribes. So we had the ecom tribe, for example, which looked after everything from the entry point of the customer through to the actual order itself, and then the fulfilment tribe, which looked after everything from the order through to the delivery for the customer. Not much change with the deployment pipelines, except for perhaps two things. So, as I previously mentioned, the number of deployments of the monolith reduced, which meant those teams that were previously working on the monolith started working on new microservices, and no one was really taking care of the monolith. So during this period, and no one really wanted to take care of the monolith either, if I'm honest. So during this period, we decided to adopt a team of volunteers, sort of a virtual team, if you like, people who stuck their hand up to say, oh, okay, every 2 weeks we'll take care of whatever small changes need to happen in the monolith and get that deployed. And so that seemed to work pretty well for us. So no one team had that responsibility on their own. In the microservices world, because they exploded quite rapidly, they exploded beyond our ability to put in some, if you like, controls in the environment. You know, so what came in during this period were some guidelines, recommendations, and even rules for things like monitoring and alerting, business monitoring and alerting. So that we got some standardization during this period, because obviously as microservices go from 1 to 10 to 100, that provides different challenges in terms of keeping the whole environment alive. And so by the end of this period, then we'd had established the traditional pyramid. You know, so a lot of unit tests at the bottom, quite a good proportion of automated functional and API tests, and then a small number of relatively more fragile UI, UX tests. And all these combined, of course, would give us our mainstay of our regression, our smoke testing, our functional testing, etc. The defect process was then enhanced by the introduction of service management. So we have a fairly lightweight operations and service team, but they play a key role in the organisation in terms of managing the communication, protecting the teams from lots of disruption as they're trying to solve problems, and identifying the correct, at least start point and most often end point for fixing defects. Because most of the microservices are independent of one another, and it's often fairly obvious where the problem lies. Last thing to mention, which is a problem that we sort of needed to solve in the next phase, was that our guild structure that we'd introduced in the middle microservice period started to break down a little bit. You know, so you can imagine with a lot of teams in the organisation, with a lot of opinions, a lot of points of view, a lot of interest, then the small committees became very big committees, lots of discussion and not much resolution of key points. So this kind of structure was breaking down a little for us. Right, so on to the sort of final period, 2019, sort of 18 months ago, the higher microservice period, so the emergence of the first humans, if you like. Not much fundamental change in our structure here. Our structure sort of scaled, but the number of teams still went up. Not so much in ecom, so we stabilised around 25 teams from 20 in ecom, but the total number of teams in the organisation run about 42 teams. The old monolith was completely demolished at this point. So I was a member of the party in the evening where we turned the final bit of the monolith off. All very good, and nothing fell over, thankfully. And the whole thing was gone at that point. Yeah. And the point I mentioned earlier around the guilds in the previous period, we replaced that yet. So there's a lot of interesting topics that we need to work on in engineering. And so we have something called the Open Friday now, which replaced the guild process. So here, anyone in the organisation, effectively, most often tends to be engineers, can bring a topic to Open Friday, and people can vote with their feet and a time slot of where to go and when. So people voluntarily choose to go to A, B, C, D, E, whatever, to attend a session of interest to them. And that tends to work quite well for us in terms of identifying new technical areas to open up or to resolve. And we immediately get an interest group of volunteers to work on that as part of the process, free in the process. I also before I wrap up, want to touch upon sort of what's happening now in the environment, and perhaps something I haven't focused on to this point, or what about other things, because obviously our microservices ecosystem covers a lot of functionality in traditional online food retailing, but it doesn't cover everything, right? There's no point in us writing absolutely everything when we can buy world-class software off the shelf, of course, that's suitable for our business. So all throughout our evolution, we've been migrating towards headless solutions, so that we don't have effectively the pain of management of those solutions, and we sort of get for free all the latest advancements for them. We don't have to worry about those. We can just use them. And that's worked pretty well for us. It suits our environment pretty well. We can communicate over Kafka fairly easily with the APIs for these services. So in terms of the product information side, we haven't written our own solution for product information. We use the Commerce Tools platform, have done from the fairly early days in the evolution, and we continue to use that today. With the content side, we started off on Magnolia, which was an inheritance really from what came before 2014. The problem that we have with the solution was not specifically Magnolia itself, but you get what you typically expect, where there's a lot of marketing push for new features in content, and the Magnolia tool itself had to become a platform in the organization with lots of spaghetti code contained within it, very difficult to upgrade, very difficult to manage, very difficult to change, etc., etc. So we're redoing our architecture now and migrating to Content Stack, which itself is a headless solution, and really looking at Content Stack as a tool and not a platform. So it exists, it does what it does it perfectly well. You get good standard workflows for managing content, particularly static content in the platform. It covers a good proportion of the marketing requirements off, and is through the workflows. And there's no need for engineering interference to satisfy those requirements. Anything out of the ordinary, which is, I guess, more dynamic or whatever, we're abstracting out into microservices as well. So the same sort of microservices architecture that we have established in both the fulfillment area and the e-com area. With our search engine, moved to Elasticsearch, only because of the horizontal scalability point. And finally, with the fulfillment side, we communicate a lot with external systems and systems in REWE Group to manage our sort of back office side, invoicing and warehousing activities and whatever, and route planning. Again, software we don't use. So we needed something that could both contain our microservices environment that we could expand to build new solutions in, and also connect very easily to new, existing or even new vendors in the future. And so we wrote the fulfillment platform. The ideas, and that's something in existence today and is getting extended all the time. And the ideas and philosophies and principles of that platform have then been taken into our daughter company, Fulfillment Tools. So we've effectively created a solution for open market based on the ideas that we had for the architecture of the fulfillment platform. Right, that's all I had. So now I'm open for questions.
And thank you for that, Dave. Thanks for sticking around for a short Q&A. Let's have a brief look at the questions that came in. The first one I have for you: did you have dependencies with your microservice deployments and monolith deployments? And if so, how did you manage them?
Well, I think the Germans would answer this as Jein. So that's yes.
I love that.
Yeah, which is yes and no. I think the truth of the matter is, for most of our microservices deployments early days, then the vast majority were independent of the monolith. Yeah, we were just building out the microservices. There were some deployments, of course, naturally, that did require coordinated deployments between the monolith and microservice, particularly where you're sort of bypassing the functionality in the monolith. So this was a matter of simple coordination of the deployments. The monolith was deployed every 2 weeks. Microservices were deployed multiple times a day. And the microservices would normally be deployed first with a toggle, a switch to the functionality off. Then the 2-week cycle would tick over on the monolith. They were deployed, and the switch, the toggle, was then activated. So there was some coordination at that level. Yeah. Although the pipelines were independent from each other. Yeah. So the deployment pipelines still are totally independent of each other.
It does sound like some coordination effort, but you quite obviously figured it out.
Yeah, it's just like cars on a road, traffic light systems. There is something required to coordinate traffic sometime.
Yeah. I have a question here. You said towards the end, there's no point in writing everything when you can buy world-class software. Is that a convenience decision? Is it just easier, or is that to accelerate your development, or because it's easier to introduce features because they bring stuff on their own? What's the key for you?
It's an economic decision at the end of the day. So every business must decide for themselves what makes them unique. What is their unique proposition that they bring to the customer, to the market, and where you need more and more uniqueness and more individuation in the marketplace, then you tend to write that software yourself. Where you don't necessarily need that, then there's a good economic reason to then say, okay, this does the job for us pretty well. I mean, we sell groceries to our customers. I mean, that's not just what we do, but that's what we do. Yeah. So everything we do around selling groceries and looking after groceries, and is we want to make that a unique customer experience and a unique customer service. Writing a content management system probably isn't top of our agenda. Yeah, we'd probably rather have more sophisticated algorithms in our warehouse, or more a cleaner checkout experience, or whatever. So that's where we put our effort, yeah, and focus.
And this is where you leverage the advantages of microservices. One question that I have here is, okay, I'm just actually seeing that we're running out of time. I wanted to ask how you're keeping them decoupled, but let's see what we can do with those
definition of microservice is decoupled, or one of them. One of them. Yes, we are.
All right, Dave, thank you so much for being here today, for a fantastic talk, and for sticking around for the Q&A.
Yeah, pleasure. Thank you very much.